said in Alicia's talk, there was already the mention of tech debt. Yeah. And I'm just going to shortcut a little bit of what might be said here. So a big education point for me from listening to watching Jabe doing a talk at Lean Agile Scotland a few years ago about tech debt was when he actually said the real issue about tech debt is not people taking shortcuts at a time, etc. Is that these systems actually never stay the same, and the environment in which they live never stay the same. So even if you do technically everything perfect at the time, just because time moves on and things change, you experience things that we then call tech debt. So could we think about tech debt as one of the ways in which we can observe complexity in software system? And
how would certainly observe temporality that way?
And how would that view help us coping with tech debt?
At least accept.
So, I mean, I think the coping question is interesting because I think Ward originally was trying to say that you have to repay debt that you get that you can't avoid not getting, and like that it's just the nature of having. So, one step back. There's an idea I call hypermateriality, and what that roughly means is things that matter, kind of like in a court case. The matter of the court is the things that are important, right? And the things that can't kind of are stable and don't change, right? And so one of the ways to think about like software is people often think of software as being kind of mutable and fluid and changeable, and that's why it's soft compared to hardware, which is hard to change, right? So they think about software as being easy to change, but that relationship of a soft thing and a hard thing, something material and something ephemeral, can be reproduced by looking at the human cognition and the system of software. Same thing happens. Humans' cognition is more mutable than the written code, right? And not just that, but like the way that software code works is it builds interactions with itself. It builds stabilities of interactions that make it very difficult. You like, as you build the thing, each little thing looks relatively independent, but when you step back, eventually you're like, if I change this thing, it changes things all over the system because it's now interacting with ways that I didn't expect it to interact, right? So there is a way in which the systems slip against each other. And one of the ways that I think about it is to say that I think technical debt is the emergence of unintended constraints on the developer. And I often say, like, the thing about technical debt is that it's like when the software starts making decisions that you think you should be making, right? Like, the reason why it's debt is because it's making you do stuff you don't want to do right now, right? It's making you take shortcuts around roundabouts. And that way, it's like the way in which I use the term actance, right? Like, it's the way in which the software starts becoming an actor in the play. And in a way that's unintended.
Is this because complex systems are path dependent?
Yes.
So
that's right.
They're bringing their past. That's your retention protension business, which is similar to Whitehead's ideas. It's sort of bringing the past with it, but meanwhile, the current circumstances have changed, and so you're going to get this mismatch inevitably.
That's right. I think that's exactly right. Yep. And so like some of the implications, the other implications are like it differentiating what people call technical debt right now, which is like the boss coming over and being like, you only have a half an hour to finish, and then you have to check in, whatever you want to say, like the kind of more contemporary versions of technical debt versus this, because in this frame, the developer can't be. It's like blameful retrospective, right? Like, you can't blame the developer for this form of technical debt. There is no way to not get there. In fact, any developer who never develops any technical debt has not learned anything by writing the software, which would maybe make you go, were you like, you didn't learn anything by writing something down, by creating a system and putting it in the environment and seeing how it worked? I didn't teach you anything about the software or the environment? Huh? Are you doing your job? Like, so it's like actually, or, you know, developers who have, I sometimes also talk about, like, developers talk about technical debt with smell and taste. They have these like very sensual descriptors of when things are starting to go wrong. And so I think like developers who have developed a sense of the software as opposed to a rational version of the software, they sense that the software is going the wrong direction. Those are mature developers. Yeah.
Is this also about like the shelf time of constraints, and that's constraints that live past their shelf time? Because like in natural systems, like proteins are constantly being broken down, messenger RNA is constantly being broken down. So it's almost impossible to live past the shelf time because it's cycling faster than maybe its useful time. Is there maybe another way of creating social, like technical systems or technical parts of our socio-technical systems that would allow us to have less technical debt, because things just by default decay, and decay is allowed and designed for?
Well, but let me suggest something different.
Mm-hmm.
In contrast to, and I shouldn't even go here, but in contrast to the new Darwinian synthesis that claims that evolution requires random chance mutations, this kind of mismatch with the past gives you a variation, which is all evolution needs, is a source of variance that might be very useful to pay attention to. Kind of like if you've got ambiguity, but then the ambiguity can't get disambiguated today, then you know, hey, wait a minute, this is telling me something about the constraints. It's telling me something about current context. It's telling me something, a whole bunch of things. And it's an important source of evolvability, of the capacity to evolve. I mean, it's kind of like people who say failure is always good. That drives me kind of crazy, but this is sort of a variation that you can't help it, because if it is path dependent, you can't stop time, and so you're not going to be able to stop this mismatch, regardless of how vague and ambiguous the constraints you write at the time were.
That's right. Yep. I think the other version of it that I try to explain sometimes is just like integration. Continuous integration is at least a hint towards what you're talking about, because when you think about it, what's happening with continuous integration is it's deferred release of information into the environment, right? By not integrating, you're deferring the information. And so one of the things I try to talk about sometimes when I talk about flow, when I talk about people like both, and I mean both flow, both kind of like the cognitive check mahele way, like people like being in the zone, but also the flow of information and stuff like that. One of the things I try to convince people is that what they don't understand is they focus so much on the speed of flow that they don't understand that actually what's more important is turbulence. That what you want is a low turbulence system that flows, and then you can make it fast. And so when you think about integration, when you delay integration, you basically release a large amount of information in the system at one time. And so you can think about, like, we did like 3-month or 6-month long development cycles. Part of what was happening is you get the developers comfortable like programming every day. And so they think their job is programming. And they program and they think about programming, they think about what they're doing. And then all of a sudden they do an integration, and then they're like, everyone stop what you're doing. We have a huge amount of defects and new information about the system. Please fix all of this now. And they're like, but I was doing the thing. And they're like, no, you can't do that thing anymore. Do this thing. And you basically like sloshing the organization back and forth between one way of thinking and another way of thinking. When you do continuous integration, what you're doing is reducing the amount of information released into the system by spreading it over time, and you allow the system to integrate the information more frequently, right? So to the extent that that's true in software, now the kind of way in which you were talking about degradation and destruction and things like that, right? Kind of the natural cycle type stuff is actually infrastructural. So the number one thing that people, I think, don't really understand is that it is so critical to be able to have the cycle time of your infrastructure be the same as your cycle time of your continuous integration. That is the way that you keep some of these mismatches from happening. Because what's happening is you're getting cycles of speed at one speed and cycles that are slower. And though that temporal mismatch, that's causing these type of slippages as well. So what you want to do whenever you're looking at a system where you get a lot of like friction or a lot of turbulence is you want to think about, is one of the cycle times significantly larger than the other? And as a first step, can I reduce the cycle time to as close so that the cycle times match as closely as possible? Because that will reduce some of this temporal slippage that's happening. And I think you can see it in a bunch of different places. In the three economies I described, kind of economic versions of that as well.
That's kind of like the harmonization at the boundaries or at the interfaces. You're going to have a bit of a difference between the two levels of organization, but the more harmonized they might be, the less one becomes a frozen constant that cannot handle the changes at this level.
Great.
But turbulence also plays an important function. It's kind of like the way bumblebees fly. But if you calculate their wing size, they shouldn't be able to fly. But then they're doing something completely weird. They're actually benefiting from turbulence, and that is actually giving them much more lift than they normally should be able to get. So I wonder if there's like a magic turbulence factor where you have just enough turbulence that it gives you just that little bit of extra lift.
Yeah, sure, absolutely. Yeah. Lift, it gives you lift.
Mm-hmm.
So the way to look at this is that the way the bumblebee has learned to cope with turbulence gave it some sort of advantage. So if there was no turbulence, then that skill would have never developed in a sense. So this is when Alicia talks about that change happens far from equilibrium, not at the equilibrium, because that just leads to death. I want to pick up, Trent asked a question which takes the whole tech debt a bit further into wider systems. So he says, is technical debt an emergent property of a system, not any single software system, but the broader industry that incentivizes a constant change to adopt the latest technology?
Like
so how
obsolescence.
Planned obsolescence.
That kind of.
I think in any knowledge work, technical debt is endemic. It's just the nature of writing. It's the nature of having two different systems that operate at different speeds interacting with each other. I just think it's how it works. I have a different kind of comment about like one of the things that happens with human interactions with evolving systems, and it's this. One of the biggest problems in technology is the users of technology often don't understand the difference between one technology and another, especially when the new technology is intended to replace an old technology. So like I use dumb versions of this. Sometimes I say like, you teach somebody how to use a hammer and you say like, this is a hammer, this is a nail. You use the hammer and nail to affix wood to a wall. You go, okay, great, yeah, sure. Go around hammering things. Then you bring them a screwdriver and a screw and you say, this is a screwdriver, use it to affix wood to the wall. And they're like, I already got one of those, I'm good. And they don't understand that there's different properties involved with screwing wood to a wall than nailing wood to a wall. They don't understand, and they don't have any practice with it, so they can't really see the result of it. To use like a more specific technical version of it, like I think that exact same pattern is why you have people who have servers that become virtual machines that become containers, and that people don't understand the difference between those things. They're like a container is just another way of deploying, just like a VM was another way of deploying, just like a server is another way of deploying. And they don't understand that, like the change from hardware to VMs was about hyperconsolidation, and it had to do with like density of compute and memory, and it had nothing to do with developers. Developers didn't care. But they thought it was a pain in the ass because they had to move these huge images around. And then someone comes up with containers, and they say, listen, the problem with VMs is the size of the images. So let's make something that is small enough that we can ship it around. And then all of a sudden, containers become part of the development process. They're not, whereas VMs really weren't, because VMs were just a destination. Containers get integrated into the way we develop software if they're being used the way that they can potentially be used. And so I think those are types of things where you get these weird slippages. One of the things that Andrew Clay Schaefer says all the time is like, most organizations you can go in and it's like an archaeological dig. You can see the year they stopped developing. Like you can see, they're just using this technology from whatever, like 2010. You're like, right, you stopped learning then. That's where you stopped learning as an organization. So I don't know.
Nice. So while you were talking about, you made the comment about removing code, there was some chat in the chat about comparison to DNA. And Piotr, I assume, asks, isn't junk DNA a part of epigenome? So he points out there is an issue about comparing code to DNA, I think.
Well, apparently people used to think that junk DNA didn't do anything, and apparently it just can reactivate in a different context. And the difference with the epigenome is that the epigenome does not change the sequence, the genomic sequence. It simply adds on these tags or methylation tags on it, and that can persist over generations. But the point being, my question that started, I think, that thread was, Jabe suggested that that's the problem with tech debt, and that it's never useful any longer. That what's left over is never. Did I interpret that correctly? Whereas in the case of DNA, it can resurface in a useful fashion in a different context.
So the way I would think about epigenetics in code would be with feature flags. So, and the way to think about this really quickly is there's an idea like you have a feature, right? It's not fully developed. It's not ready to go into production. It's not ready for the public. There's a way of thinking about it where what you do is you keep it on a separate branch and you don't merge the branches together, and therefore it's not released when you do the release, right? Okay. And one of the arguments there is you're delaying integration, blah, 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 all the other stuff we talked about. But the other thing is to roughly say that it might be valuable to, so a feature flag basically means you can turn that feature off. You can like say nobody can actually see this in the interface.
Right.
So the argument is with feature flags is that you deploy it into production because often that code is actually still being exercised even if the end user can't necessarily see it directly. Okay. And then you can turn the feature flags off and on. So that would be to me like that hidden situationally activated code would be more like that feature flag. Epigenetics is kind of like how I might think about that. Where the part of the value though is that the code is being exercised. So the point that I was trying to make is like, if you find code that never is exercised, like there's weird ways to do this. You can literally put pointers in the system, and if nobody ever calls the method, then it's probably safe to remove, and it's probably better to remove it because eventually when you try to exercise it probably won't do what you expect it to.
Okay.
But is the unit of evolution really the piece of software? Like, isn't the unit of evolution all the different applications that you're using together inside of your team? So I think that, like, the genome is probably more like your full code stack, like of all the stuff that you're using.
System, right.
Yeah, and there's a lot of dormant stuff in there, a lot of cruft also.
But again, I mean, like, this is like a prime example of some of the dangers of it, right? Like, if you are a public bank and you're using open source software, something like 95% of the code you're putting into production is stuff that you didn't write, don't know what's in there, and God only knows what you're running, but you're putting it into your production environment. Yeah. I think it's super interesting. Most of the hacks are these, a lot of the bigger hacks these days have to do with people injecting malicious code into open source software years ago so that they can express it in the future. They let it lie dormant.
But that feels that it's like the microbiome, like the bacteria that have their own devices on what they're going to do with your body. It's just where we're co-opting bacteria because they help us digest stuff that we can't digest on our own. Fascinating.
Although I would advocate not to look at the bacteria in your gut as independent or autonomous. Yeah, so because we have co-evolved with them.
Symbionts, right?
Yes. Or, I mean, I often say this. Jay pointed this out. Actually, he said, in order to talk about a thing, we have to create a boundary. And forgive me, when I tweeted it, I actually said that this boundary isn't real. So if we say here are humans and here are bacteria.
Correct.
These are artificial differentiations that we're making in order to talk about things. You could easily look at it from a metabolic point of view, and you just see chemicals flowing between the two. And
I don't think it's just our categories. I think it's that there are levels of organizations of constraints, and so some along. I really do think it's ontological, and just it depends on whether we get the right lens to see that set of interdependencies.
The problem we're trying to understand.
Correct.
Yes, I'm not saying they're never useful.
Yeah.
There's this movie that I love to play for people when I talk about the idea of levels. It's called The Powers of 10, and it basically starts out like at the microbiome and it goes all the way up into the stars and back. And I like to make people watch it, and then I go, I want you to notice that at each power of 10, there is a scientific epistemology specifically addressing that power. And that's not random. Like, the reason why that epistemology exists is because it's effective for dealing with that level of the ontology.
Correct.
And the challenge, of course, is the way in which, as you go up and down those things, the epistemologies change, and they don't necessarily interchange well, right? Correct. Like, they don't relate well to each other, and that can be very confusing.
It's asymmetrical, right?
Yep. And one of the ones I always like to talk about is the weird way in which, like, one of my favorite things to think about right now is, like, a lot of what we think about as living beings is a very thin layer on top of the crust of the planet. It's like the actual place we live is like razor thin universally. And so you get this weird thing where, like, when you go above it into the astrophysics and stuff like that, and when you go below it into subphysics, particle stuff, like, weird things happen on either end of those things. And the weird thing that I think that happens, I don't know if they do this anymore, but they used to teach the, like, planetary atom. Like, they would make it look like a solar system because it was easy to understand. It's like the solar system's like this and atoms are like this. Of course, atoms are nothing like that. So they were trying to, like, match these epistemologies so that you could make sense of them as high schoolers. I think that's weird.
But that's also historic, that at some point when they tried to understand what happens at atomic level, they had the planetary model already available, so they applied it and it explained a few things, and only later they figured out, oh, that doesn't work anymore. So here we found now things that break the model.
That's right.
But that's often the problem also that we're experiencing. So quite a few comments were, how do we use this knowledge in business? Because they just want solutions. Yes, it's this common. It's not quite a stereotype because I think most of us have experienced this. Senior people say, don't come bring me problems, bring me solutions. Yeah. But what you showed very nicely, Jabe, with your model, is in order actually to get to good answers, first of all, if you accept the answer is temporarily limited, as in it's only a good answer now and tomorrow might not be a good answer anymore, but also we have to literally iterate our understanding on the problem. So we have to take a step in, and this is often a good way how we can understand complex system is we have to do some interaction or intervention. And then the system pushes back or plays back, etc., and then we can learn something about it. But as many of us struggle in non-exec positions in organizations, how can we bring this thinking into organizations in a way that we don't get just put in the corner and say, yeah, you with your crazy ideas, that'll never work here. Or, I mean, Alicia, from your perspective, how does that work running in an organization? I bet you have seen business models before to say, here's how an executive has to behave, and I doubt that is what you do.
No, but I like the idea of the platforming and the fact that you can design for a constraint regime that is wider, that is flexible, that allows for variations in realization. And I wish I had the example of the architect who designed a building and then he did not design the paths to the parking lot from that building. Who I really wish I had the exact name and wherever that was, but allowed some time before you could tell what the users in the building, instead of going out the front door, they found it easier to go out the garage, the back entrance, because that was closer to where the parking space was. And so you can design for the generic rather than for not even the specific, but for that particular phenotype, And so by designing for the genus, which is a more flexible constraint structure, you allow the species and the species in the phenotype to, through local context-dependent constraints, modify the topography and create the different Waddington landscapes, if you will, or whatever. So you just design for the space of possibilities, which is your platforming thing, right? And that gives you constraints. That's not a free-for-all. That's not a amorphous, homogeneous space. It gives a certain amount of constraints, but it's more like fields of flow. You're designing the field, and then you allow the individual local situation to give you the trajectories within the fields, if you're going to follow that metaphor. I think.
And the thing that I would say, the main thing to try to convince a lot of managers right now about is everybody's been so immersed in RASCI charts and RACIs and responsibilities and, subdivision of labor and responsibility, and almost no one has been taught to think about relationships between teams of technology, and the value to be had, I think, is a lot to do with how the relationships work. So like really simple versions of it is like, if you have role descriptions and your role descriptions don't say what other roles you work with and what types of interactions you have, you might not be using complexity to inform your organizational structure, you might be using reductionism to inform your structure, right? So maybe that's one place to start. And then the second one is, like, again, around platforms and ways in which software engineers interact. If you look at a platform, if you still are thinking what we're going to do is define really clear interfaces, and then people are just going to plop into the platform their weird thing that used the interfaces but didn't modify them anyway. Again, you're just slowing the evolution of the system down significantly. Instead, you could think about, like, how do we create an environment that encourages teams to contribute and modify the platform in a way that becomes more and more effective for what they need, and in particular accelerates the differentiation at the edge of the system, while consolidating it by using the right kind of constraints that enable the acceleration in the platform core. That's really, that interaction is important. And I think, the problems that I end up having with ideas like platform as a product is that they imagine that the platform is like an edge, and it's not like an edge. It's a set of constraints that enable the edge. And I think that's really critical for people to understand.
We're nearing the time. I would love to just keep it going, but...
Well, we're going to have an unconference in October, so
yes,
we are keeping it going.
We're keeping it going, yes. Thank you both.
Thank you, Fred. That was fun.
For all the time that both of you have put into this, because I know how much effort you've done, both of you, to make this work. Thank you for teaching us, and for...
But also, thank you for the audience. They're great participation.
Goodness, these folks stayed.
I feel a bit sorry for Jade that he can't go back and see comments that Alicia made during his talk. Very supportive. Nothing to worry about. But
thank you,
guys. I'll see you guys soon, I hope.
Bye.
Yes.
I'm gonna go run and get on a plane, go home.
Where are you?
I'm in Salem. I'm actually directly across the street from the House of the Seven Gables.
Oh my goodness!
In a 200-year-old
Take a picture.
House.
Yeah. Watch out for the witches.
Exactly.
See, I asked him whether he went looking for them.
Okay.
Thanks, guys.
See you tomorrow. Bye-bye.
Yep. See you tomorrow. Yeah.